Hi everyone. Today we are going to learn basic electrical engineering key points. Let's start our session. Yeah, these are the basic terms here: current, voltage, power. Current is nothing but rate of flow of charges, or dq by dt. Q stands for charge and units here as amperes. Voltage is nothing but it is a work done in bringing a unit positive charge from one point to infinity. Maybe call it as voltage or else potential difference, and the units are volts. Power, rate of doing work, dw by dt. Or else we can write it as product of voltage and current, power there, and units are watts. And these are the basic electrical elements here: resistor, inductor, capacitor. And units for resistance here is ohms, inductor here is Henry, capacitance here is farad. And the main behavior of resistor here is which opposes the flow of current. This one which stores energy and magnetic field, capacitor which stores energy and electric field. And we'd like to know the voltage equations: V equal to IR, whereas for the inductor V equal to LdI by dt, V equal to 1 upon C integral I dt. In a similar fashion, I equal to V by R, I equal to 1 upon L integral V dt, I equal to C dV by dt. And power in this particular resistor here is V into I, or else I square R or V square by R. Coming to the part of inductor which stores energy here now, E is equal to half Li square, and units for energy here is joules. E equal to half CV square in terms of capacitor. According to the Ohm's law here, at constant temperature, voltage across an element is directly related to current flowing through that particular element. And I'd like to remove this proportionality constant now, replace that one with the help of some R here. It's a constant resistance, V equal to IR. Coming to the limitations wise, it's not applicable to unilateral elements and nonlinear elements. Unilateral in the sense, let's the example here is diode. Nonlinear elements here is it's also diode. Applications wise, it can be used in terms of conventional fan regulators in order to increase the speed levels, whereas voltage divider circuit in electronic gadgets also we are using this Ohm's law. And we are having some DC ammeter, or else we can use it in measuring instruments. These are the different applications of Ohm's law. Coming to the Kirchhoff's current law and Kirchhoff's voltage law. Kirchhoff's current law here is it mainly depends upon law of conservation of charge, whereas KVL it mainly depends upon law of conservation of energy. Sigma I is equal to 0, sigma V is equal to 0. Sigma stands for algebraic sum of currents meeting at a junction or node is equal to 0, or else sum of the incoming currents is equal to sum of the outgoing currents. Whereas in terms of this one, the algebraic sum of voltages and a closed path is equal to 0, or else summation of voltage rises is equal to summation of voltage drops and a closed path. Coming to the part of series and parallel connections wise, in series connection, the current is same throughout the circuit, whereas in voltage will divide. Let's observe these two resistors are connected in series. Current is same, but voltage will divide across this resistor 1 and resistor 2, V2. And the equivalent or summation of these two resistance is nothing but equivalent value. R equivalent is equal to R1 plus R2, which are connected in series. Whereas if two resistors are connected in parallel like this, in that voltage is same throughout the circuit, but current will divide. That current may be I1 and I2. And the equivalent value may be the formula here as 1 upon R equivalent is equal to 1 by R1 plus 1 by R2. These two formulas are same for inductors connected in series and parallel connections. Whereas in terms of capacitance is reciprocal there. Coming to the superposition theorem, I'd like to explain with the help of some simple circuit here. Actually, I'd like to find out current flowing across 8 ohms. Kindly observe this, how many sources in this particular circuit here is 15 volts and 10 volts. Two sources, no? At a time, according to the part of this SPT theorem, we have to observe here is at a time, we have to connect only 15 volts. That it is only one source has to be connected and the remaining every source has to be deactivated. Observe 15 volts is in activation mode, whereas 10 volts I would like to keep it in active mode. That it is, I'd like to make it short circuited like this. Then I'd like to find out current flowing across same 8 ohms, that would be I1. In a similar fashion, the second circuit may be 10 volts is in active mode, whereas I'd like to keep it the 15 volts short circuited like this. Again, I'd like to find out current flowing across 8 ohms here as I2. The summation of these two currents is the total current value when all the sources are active. These are the only one source is active, and summation is equal to total current value. This one is a simple procedure we have to follow for superposition theorem. Coming to the part of AC. AC stands for alternating current. That we'd like to opt for the part of sinusoidal waveform like this. Let it be, I'd like to have this y-axis term maybe voltage or current or power, whereas this x-axis may be time axis, which is measured in terms of milliseconds. For this, I'd like to choose some current waveform like this, and I'd like to write some sinusoidal equation for the current here as I equal to Im sine omega t. Omega is nothing but angular frequency. Im is the maximum value. In this waveform, observe what's the maximum value here. They have given some 5 amperes. The name here is maximum or else peak value. What's that peak to peak current here is, observe from this point to the part of positive peak to the negative peak, how much 5 minus 5 here is obviously 10 amperes is a peak to peak value. From this point to the part of this point, you have to measure it. That value may be called it as peak to peak current value. Time period is nothing but how much duration had to cover for a positive half and negative half. That it is 1 cycle. That value here is 0.8 milliseconds. The reciprocal of this time period will give us information of frequency term. In Indian standard frequency, we have to follow our frequency here as 50 Hertz. Yeah, these are the two formulas you have to follow for factors wise, form factor and peak factor. Form factor is nothing but its RMS value to average value. Kindly observe the screen colored one, RMS value to average value. For the sinusoidal waveform, it's approximately 1.11. Peak factor is nothing but peak value to RMS value, or else we may call it as crust factor. For the sinusoidal waveform, it's approximately √2, or else 1.414. These two triangles plays a crucial role in terms of electrical circuits: impedance triangle and power triangle. Impedance triangle Z is equal to R plus JX. Z stands for impedance, R stands for resistance, X stands for reactance. S is equal to P plus JQ. Apparent power or total power, active or true or real power. Whereas Q is nothing but reactive power. Observe, I'd like to draw some resistance here. Perpendicular to the resistance, you have to draw some X. The hypotenuse may be called it as Z. From that, can you identify what's that cos phi is nothing but adjacent side divided by hypotenuse? It's obviously R by Z. In terms of a technical point of view, this one may be called it as power factor. In a similar fashion, from this power triangle also, cos phi is equal to that it is true power divided by total power. Will give us information of power factor. These are the formulas you have to follow for active power: VI cos phi, Q is equal to VI sin phi, S is equal to VI. And the units are kilowatts, kilovolt ampere reactive, kilovolt amperes. Thank you.